Now we have to talk about the units where MUX is less than PX. Like for 5, 6 and 7 unit, you can see here the MUX is less than PX. So all these units when consumed, they lead to decline in the consumer's surplus. You can see after this unit, consumer surplus has started decreasing. So it is maximized here. So it means that when the consumer consumes only 4 units of that commodity, he will be in equilibrium, or he will be able to maximize his total satisfaction. This is a numerical example. You can simply graph any numerical example. Just take a constant price, MUX declining due to the law of DMU. Okay, you will just have to remember, make any point where these two are equal, and similarly you can calculate at the consumer's equilibrium, because the question may be asked, explain the consumer's equilibrium of one commodity case with the help of numerical example. So this schedule is to be made. Theoretically, a question may be asked to explain the conditions of the equilibrium, right? So you have to tell that again using the method of elimination why the other two cases are not, conditions are not the equilibriums, that is MUX greater than PX and MUX less than PX. Now diagrammatically also we can explain this. Taking units consumed on x-axis and MUX and PX on the y-axis. PX remains constant, MUX diminishes due to the law of DMU. This is the point of equilibrium where MUX is equal to PX. All these, this particular area shows the consumer surplus, total of the consumer surplus or the consumer's gain, because for all the points lying on this particular line, MUX is greater than PX, while this particular area shows the loss of the consumer, because here for every point PX is more than MUX. So this is the consumer's one commodity case. You have to remember it because it's a very important topic, and a question may also be framed in the way that given the price of a good, how would the consumer decide how many units to buy. So again you have to answer it on the basis of one commodity case, that he would decide on the basis of the marginal utility and the condition. Next we have to move on to the two commodity case. Here the consumer is assumed to consume two commodities, say good X and good Y. You have to remember that here the law of DMU is modified to law of equimarginal utility. This law of equimarginal utility, it is very important. Actually it is the first condition of the equilibrium under the two commodity case. As you can see, equimarginal utility. So this law states that a consumer tries to allocate his expenditure in such a way that the utility per rupee of X is equal to utility per rupee of Y. Already we have done how to calculate the utility per rupee. As I gave you an example, say the marginal utility of a derived from a unit consumed of a commodity is 80 and the price of that commodity is say 10. So it means utility per rupee is 8, that is 80 divided by 10. Or simply you can say that if you spend 1 rupee on this commodity, you will get 8 utils of utility. So utility per rupee of X can be written as MUX upon PX, while utility per rupee of Y can be written as MUY upon PY. Right? And this law says that both should be equal. So you can call it in the various statements, like you can say the ratio of the margin utility to x and price of x should be equal to the ratio of margin utility of y to price of y. You can also say that utility per rupee of x should be equal to utility per rupee of y. They both mean the same thing. This is also the first condition of the consumer's equilibrium under this approach. It actually means that the consumer should maximize the satisfaction which he can attain from x and which he can attain from y. Neither he should lose in terms of x, neither in terms of y. So the conditions of the consumer's equilibrium under the two commodity case. First condition, as we said, law of dmu, that is mu(x) upon px is equal to mu(y) upon py, and second condition is qx into px plus qy into py is equal to income. Okay, this you can also call as budget constraint. Constraint means the limitation and budget means the income. So consumer cannot go beyond his income. So first we will talk about the first condition, right? Actually the condition is itself reinforcing, means whenever you disturb the equilibrium it will regain. As I told you that for explaining a particular condition you have to follow the method of elimination. So here two possibilities become that mu(x) upon px is greater than mu(y) upon py and mu(x) upon px is less than mu(y) upon py. Look at this condition. What is it telling me? That if I spend 1 rupee on x, I get more utility as compared to a rupee spent on y. It is actually the utility per rupee of x and it is the utility per rupee of y. So as a rational consumer, what I would do, I would purchase more of x, right? And when I increase the consumption of x, then mu(x) falls. This I have already studied in the law of dmu. Then if mu(x) falls, it leads to fall in mu(x) upon px. As you can see, because px will remain constant, mu(x), its value will decline. Suppose the value of the numerator is declining, the value of the fraction also declines. And this continues till mu(x) upon px becomes equal to mu(y) upon py and equilibrium is re-established, right? So these can also be called as the chain of effects. The question would be framed in the form of chain of effects, or the reactions of the consumer if mu(x) is equal mu(x) upon px is greater than mu(x) upon mu(y) upon py, or maybe it may be asked that what chain of effect would take place, or a question may also be framed by giving you the values of mu(x). Say they say mu(x) is 10 and say px is 2 and mu(y) is say 20 and py is say 10. So you simply have to just put in the values, right? Put 10 by 2, that is equal to 2 mu(x), and 20 by 10, that is equal to 2. So they are equal, it means the consumer is in equilibrium. While if it would have been 3 and 2, then it would mean that this condition is taking place and same chain of effect. Similarly in this case, just vice versa, in this case consumer will consume more of y, leading to fall in mu(y), leading to fall in mu(y) upon py, and till the equilibrium is re-established. This is a very important condition. Questions are often framed from this particular condition, so you have to understand it properly. Then moving on to the second condition of the equilibrium, that is qx into px plus qy into py is equal to the income. As I told you, it can also be called as the budget constraint. or limitation, means consumer cannot go beyond the income. Again, method of elimination can be used. Two possible situations, qx into px plus qy into py less than the income, and qx into px plus qy into py more than the income. If you have any doubt, you can just understand that qx into px means the total money spent on x. Suppose you bought 2 units of commodity x and price of the commodity x is 3. So it means you have spent 6 rupees on commodity x. Here it says, and similarly for y. So it is actually the total money spent by the consumer, and this side you have the income. This says that the total money spent is less than the income. It means that consumer is not consuming maximum possible, or rather you can say that he is saving the money. And in the consumer equilibrium, in the beginning we said that money should not be saved because it itself doesn't have any utility, it cannot give you any satisfaction. While here it is not possible, because here we are not talking about any credit. You have to spend the money, then only you can attain your equilibrium. So you cannot spend more than your income. Suppose you have 100 rupees with you, you can buy only the goods worth rupees 100 and not more than 100. So these are the two conditions of the consumer's equilibrium under the two commodity case. Questions can be framed from here. Okay, then if we look at it diagrammatically, then you can name these axes R1 and R1 and O1. On one axis I show MUX upon PX, and on the other axis I show MUY upon PY. See, both of them would be decreasing. They would be decreasing because of the law of DMU. You must understand that law of DMU states that the marginal utility goes on diminishing. On this axis I have